Hello, students. This is Vishwajeet Poddar, Chemistry NEET faculty from Altedemy. Before I move ahead or before I speak anything, I would like to know about the quality of broadcast first. Are you finding it okay? The quality of broadcast. Can you hear me? Hello, Sangeeta. Can you hear me? Okay, let us move ahead. The second thing that we would always be interested in asking, how is the state of preparation of your medical entrance examination? If you can rate your own preparation on the scale of 1 to 3, how do you rate? You can go ahead. Hello Kushi, you're welcome. I hope I am audible. You can hear me. Okay. Well, this is Vishwajeet Poddar, Chemistry NEET faculty in Altedemy. I have a very long experience of teaching students who are preparing for NEET as well as JEE entrance examination, and I'm here in Altedemy with you to help you getting your success. Hello, Chinnarekha. Good evening. Kushi, good evening. Army lover, good evening. Okay, I hope you will enjoy this session. Right? We are talking about thermodynamics, and this lesson of thermodynamics I'll be discussing with you with a different note, and I know it fully well that you have studied or you are studying thermodynamics in physics as well as in chemistry. Many of you might be confused about this particular fact, why thermodynamics is being taught in two different subjects, physics as well as in chemistry. What is so special about it? And what is the difference in teaching thermodynamics in physics and in chemistry? So, are you ready with Altedemy to move ahead to know about thermodynamics? Okay, here we go. Look here. Whenever you are studying thermodynamics in chemistry, and for that matter, even physics also, you should bear in mind that we will always be talking about a gaseous system. We will always be talking about a gaseous system. There is a container, there is a movable piston, and in this container and in this movable piston, when there are movable piston, there is a gas inside it. Everything about thermodynamics will be revolving around a gaseous system. Well, we have one more chapter which is attached with it, and we call it thermochemistry. Thermochemistry. In your basic books, where thermodynamics ends and where thermochemistry starts, often you are surprised for it. But you should know the fundamental difference. In thermodynamics, we are essentially talking about a gaseous system. In thermochemistry, we are essentially talking about a reaction system. In physics, you do not talk about thermochemistry. They do not have a provision for a reaction. They have a provision for gaseous system, and obviously, whenever they are talking about thermodynamics, they are also talking about gaseous system. But we are talking about thermodynamics and thermochemistry, both the things, because chemical reaction is everything for us. Our every discussion, every theorization revolve around a reaction. That's why thermodynamics, when we are dealing with a reaction system, we call it thermochemistry. Well, a matter in gaseous state neither possesses a definite volume nor a definite shape, but it has a definite mass. This is something which it acquires the shape and volume of the container. Some common examples are air, oxygen, carbon dioxide, etc. You know these things, I understand. Okay. Well, right now I am reducing our entire discussion related to thermodynamics. Let us just try to understand. If we are talking about a gaseous system, what are the things that will come into picture? Which are the things that we will be taking up? Khushi, I am teaching chemistry, thermodynamics. I am teaching chemistry, thermodynamics, right? Okay, thermodynamics, whatever is taught in chemistry, that I will be teaching. I'll be letting you know the things that you will be studying in physics also, but then mainly I am teaching thermodynamics in chemistry, right? So if we are dealing with the gaseous system, if we are dealing with gaseous system, what are the parameters? You can talk about pressure, you can talk about volume, you can talk about temperature. Generally, we deal with the closed system, so we ignore n, but you can take even n, which is number of mole. Apart from this, we talk about Q, that is amount of heat, W, that is amount of work. Besides, we are also talking about delta E, that is change in internal energy, or a delta U. These are one and the same thing. We often use it. Internal energy. Change in enthalpy, we will be talking. Change in entropy, we will be talking. Change in Gibbs free energy. These are some of the parameters, rather all the parameters that we have discussed. There are some others also, but these are mainly the parameters where we will be discussing about thermodynamics. We will be talking about pressure, volume, temperature, number of mole, amount of heat, work done, change in internal energy, change in enthalpy, change in entropy, change in Gibbs free energy. Their interdependence and making some particular unit constant, and then the variation of some particular terms also we will be handling in these cases at a higher level. But right now you should understand these are mainly the terms that you will be coming across when we will be studying thermodynamics, right? Okay. Thermodynamics means flow of heat. The branch of physical chemistry which deals with the relationship between heat and other forms of energy in chemical, biochemical and physiochemical process is called as thermodynamics. Right now we are concentrating our study about thermodynamics in chemistry. Okay. Here I would like to point out one more thing which you should know right in the beginning. When a physics person is handling thermodynamics and when a chemistry person is handling thermodynamics, what is the difference that they generally perceive and what effect does it cause? In physics, normally what happens that they have machines in their mind. And you can look at any of the machine. What does machine do? Like we have a car, motorcycle, whatever you might have seen. You put some petrol into it, give the ignition, and then it moves. So for them, the positive parameter is heat given to the system. Heat given to the system. They say it is positive. Heat given to the system positive. Well, we are giving petrol to the vehicle, and giving petrol to the vehicle, it's a positive thing. And secondly, when we put petrol into the vehicle, it moves, it does work. So they say work done by the system. Work done by the system. It is positive. Opposite we can do. Heat given to the system positive. Heat given by the system negative. Work done by the system positive. Work done on the system, this is negative. This is the convention, sign convention that physics people are using when they are handling thermodynamics. And why are they doing it? That matter should also be very clear. They have machine in their mind, and the way machine behaves, their thermodynamic conventions have come accordingly. If we put some energy into a bike or a car in the form of petrol, then it starts giving work. So heat given to the system we called positive, work done by the system we called positive. But how does a chemistry person thinks? That also you should know. A chemistry person will always ask that the unit of heat or unit of work both are joule or calorie. Unit of heat, unit of work, both are joule and calorie. So if heat given to the system positive, then obviously for us work done on the system, that is positive, or that should be positive. And there lies the whole difference. There lies the whole difference. And the difference that we will be clarifying to you in physics, work done is equal to, it is said as P delta V, but in chemistry, wherever you will be writing W, we will be writing minus P delta V. Everywhere we will be writing work done is equal to minus P delta V, right? Okay, we will elaborate onto this matter further. Let us first try to understand the things from the very beginning. Look here. We will always talk about system and surrounding. As I told you, we have a container, movable piston, some gas inside it. That's a very rudimentary, very basic structure that we handle as far as thermodynamics is concerned. So this entire volume of this particular substance, you can understand there is a piston, there is a container, all those things, there is a heating equipment, we are heating this substance, and this entire thing will be called as system. And the space outside the system will be called as surrounding. Surrounding. System and surrounding. These are the two things that we will always be having. So, as far as system and surrounding are concerned, in thermodynamics, basically what is happening? There is transfer of heat from system to surrounding or surrounding to system, both ways. Work, either by surrounding work is being done onto the system or system is doing some work onto the surrounding, both the things are happening. So everything will be calculated keeping in view the parameters of system and surrounding. The frame of reference of system we should build up. At times it is imaginary. Like we will understand, it is quite understandable that this should be what it should be called as a system. System obviously has got a boundary. So coming to that part of things, how many types of system that we will come across? System is there. Look here, these three types of system that we have mentioned. One is an open system, another is a closed system, third one is an isolated system. What is the difference between these three kinds of system that we will be encountering? Open system, closed system, and isolated system. Mostly we will be talking about closed system. The thermodynamics rules and other things, whatever have been framed, it has been framed keeping in view the closed system. But then we have different kinds of system that you should also know about. Between the system and the surrounding, transfer of matter or energy takes place. A system that can exchange both matter and energy with its surroundings is called an open system. So if it is an open system, then matter and energy both are transferred, or not transferred, both can be exchanged. And it is an open container. Suppose you are boiling water in a container and the container is open. When the container is open, then water particles can also go into the surroundings. Water particles can go into the surrounding. So matter is also exchanged, matter is also being transferred. And obviously, if you will put your hands there, you will feel the heat. So energy is also being transferred. So in an open system, matter and energy both are transferred. But if you close this container And if you close this container, then you do not allow any of the matter or water particles to go outside. So for a closed system, matter, no. Energy, yes, it can be transferred. And then we have a third situation where we call this neither matter, no energy. It is called as perfectly isolated system. Sound is poor. You're not able to hear. I'm screaming here. Sangeeta. Others also please respond if you're not hearing me or sound is okay. Sangeeta says that she's not hearing me properly. Are you all hearing me? Because that is the maximum voice on which I can speak. I'm speaking at the maximum pitch. Anyway, let us see. If the sound is not coming, then let me know once again. So we have these three kinds of system: open system, closed system, and isolated system. And if you will talk about an isolated system, we do not have a perfectly isolated system. No example of perfectly, isolated system. Generally, we give an example of universe when we are talking about a perfectly isolated system. Okay. Sangeeta, I'll request you to see your own device. Probably there is the sound is low, sound quality is low. That's why you may not be hearing me properly. Otherwise, sound is coming. Okay, Aruna, thank you very much. Okay. We talked about open system, closed system, and isolated system. We have three different kinds of system: open system, closed system, and isolated system. In open system, there is energy, there is a transfer of matter as well as energy. Both can be exchanged. In a closed system, there is no matter that is being exchanged, but energy can be exchanged. Yes. In an isolated system, there is neither matter nor energy. Nothing can be exchanged, and it is like that. Okay. Coming to another part of it. We have various types of process. And if the temperature of the system remains constant during a change, then the process is called as isothermal process. If in the entire process, good evening, Ilma. If in the entire process temperature remains constant, you had seen Boyle's law, where we said about pressure and volume. We drew the graph of pressure and volume, and we had graphs like this, and on these lines temperature were constant. So this was basically an isothermal process. Isothermal, iso means equal, thermal is temperature. Isothermal process. If the system does not exchange heat with the surrounding during a change, this process is called as adiabatic process. In adiabatic process, in isothermal process, we say T constant. In adiabatic process, we say Q is constant. Q. We told you about T, V, P, Q. Q is constant. If during a process heat transfer is constant, then it is called as adiabatic process. If pressure of the system is kept constant during the change, it is called as isobaric process. Here pressure is constant. We can run a system by doing all these methods. We can run a system keeping temperature constant. We can run a system keeping Q constant. We can run a system keeping pressure constant. We can run a system keeping volume constant. All these things can be done. Right, so we have different kind of processes that we will be understanding. We will be understanding the things graphically. Look here. I would like to draw it for you. Suppose we should understand this. We are drawing a PV diagram, which is very important for you. Pressure we are keeping here. Volume we are keeping here. You should recall Boyle's law that we had discussed. And we are making a general PVX is equal to constant type situation. PVX type situation. And I am drawing various lines here and I will elaborate it just now. Look here, 1, 2, 3, 4, like this. It is called as an expansion PV diagram. Expansion PV diagram. If we name this process as first, name this process as second, name this process as third, fourth, fifth, and sixth. Look about all those processes. What are we doing? Let us talk about process number 1. What we are noticing, that pressure is constant. So if this formula has to be converted into pressure is equal to constant, then V to the power x should be equal to 1. Then the value of x should be 0. Then only we can have P is equal to constant. Do you agree with me? If for this line, if we draw this formula like P V to the power x is constant, then for x we will have to take 0. If x is 0, then V to the power 0 is equal to 1. Then we get P is equal to constant, and in this graph we are seeing that pressure is constant. Come to the sixth portion. Suppose this is the sixth portion. Here we are writing P V to the power x is equal to constant. Here we are noticing that volume is constant. Let us try to formulate it. V to the power x is equal to constant divided by P. And that means V is equal to constant upon P to the power 1 by x, isn't it? And if we put x is equal to infinity, if x is equal to infinity, then we get constant upon P to the power 0, which is equal to 1. And now we can say V is equal to 1 and it is a constant situation. That means in this situation x is coming to be what? Infinity. So notice it. This value of x is increasing from 0 to infinity. In this process when we are moving this way. 0 to infinity. The second one is basically PV is equal to constant, where x has got a value of 1, which is called as isothermal process. Isothermal process. Look, what this process number 1 can be called as. Pressure is constant. We call this process as isobaric process. The second process is what? Isothermal process. And you should know, about which I will be elaborating in a short while. The process number 3, 4 and 5 all are adiabatic process. And for adiabatic process, soon you will realize, soon you will understand, the value of x increases from 1.33, x is equal to 1.40 and x is equal to 1.66. These values are coming. This is for a triatomic gas, this is for a diatomic gas, this is for a monoatomic gas, like this. And the general formula is PVX is equal to constant for an adiabatic process. Rather, we write it PV gamma is equal to constant. And the value of gamma, I will show you that it is ranging from 1.33 to 1.40 to 1.66. Right? Did you understand, or did you find any difficulty in understanding these things? I just wanted to let you know what are the different type of processes. Isobaric, isothermal, adiabatic, and the last process was isochoric process. Graphically also you should understand. Isothermal, adiabatic. Look, the expansion, this was expansion curve. You can also draw contraction curve. about which I will be telling just now. The second thing is we call this as extensive and intensive properties. It's a very small thing, but there are always plenty of questions. Good evening, Khushi. Good evening. There are variety of processes that you will come across and which is called as extensive and intensive property. Look here, there is a very small list, can be very long. List can be very long, but I am giving you a small method to identify which properties can be called as an extensive property or which property can be called as an intensive property. Look here, I am just elaborating it with an example. Suppose you take a water in a container, right? You have taken water in a container. This is your first situation. And you have kept the temperature of water, this is temperature of water, as let us say 90 degrees centigrade, or it is boiling water 100 degrees centigrade, something like that, right? And we put a very small partition in between and analyze the second situation. There is a partition, water is here, and we have put a partition in this manner so that it does not disturb the properties of water. This is a very thin, small, very thin partition. Now look at two different things. One, you look at temperature, another you look at its volume. Look at its volume as well as temperature. What do you think? Now in the second situation, what will be the temperature of this side? If initial temperature was 90 degrees centigrade for the entire water container, if you put a small partition in between, do you think that that temperature will be halved? Obviously not. The temperature of water this side or temperature water this side, both will be having 90 degrees centigrade. This is a very common understanding. Right? If you are having water, boiling water, suppose you put a small partition into that water, do you expect that the temperature will become 50 degree or 45 degree? Obviously not. So by doing this partition, the value did not change for temperature. By doing this partition, the value did not change. So we say such properties as intensive property. Intensive property has got a universal appeal. It does not change. Like you take density. We never say the density of 1 kg of iron. We always say that density of a particular substance. Density of iron, whether it is 1 kg iron or 500 gram of iron, like this. So it is density. It is again intensive property. But look at volume. Once you have done this partition, volume gets halved by doing this partition, isn't it? So we call this as extensive property. Now the crux of the matter is what? The property of the system, read the statement that I have written, the property of the system that depends on the total amount of the material present in the system is called an extensive property. The properties which are dependent upon the quantity of the substance is called as extensive property. Mass, volume, heat capacity, internal energy, enthalpy, entropy, gives energy are all extensive properties. Extensive, mass dependent, and those properties which are mass independent. Look, we have written many of the property: density, viscosity, surface tension, specific heat, boiling point, freezing point, pressure, temperature, refractive index. Molar properties like molar volume, molar entropy, molar heat capacity are intensive properties. So properties can be explained intensive and extensive by these two manners or methods. We discuss extensive and intensive property. Let us talk about state and path function. I'll elaborate it very briefly. We had discussed about 10 such things, almost 10 around. Let us number it: pressure, number 2 volume, number 3 temperature, number 4 number of moles, number 4, number 5 Q. Number 6, W. Number 7, change in internal energy. Number 8, change in enthalpy. Number 9, change in entropy. And number 10, change in Gibbs free energy. You will come across these things only. Out of these 10, there are just 2, Q and W only, which are path function. I will elaborate you with a very good example. What exactly do we mean by a path function? But before I give you some example or something, I would like to know, I'd like to make you aware about Altedemy and the Telegram channel of Altedemy. You should immediately join our Telegram channel, and I hope you must have joined. Probably that is why you are here. Once you will be joining it, you will be getting plenty of PDF materials. There are a lot of free classes. There are a lot of announcements which are of great importance for you about the date of examination, when the forms for NEET examination are going to be filled. There are a lot of discounts and prizes that you will be getting. So join it immediately without making any delay. Okay. Moving ahead. Look here. Suppose a person has got a checkbook he has, and he has to give somebody some 10,000 rupees. He wants to give somebody a 10,000 rupees. He has money in his bank. He wants to give somebody some amount of money, let us say 10,000 rupees. So just he, takes out a checkbook and just signs 10,000 rupees and delivers it to that person. He goes there and gets it encashed. Now what has happened? With the mode of this particular check, the money has been transferred. With the mode of this check, the money has been transferred. Look, before this process, the check had no value. And once it has been encashed, then again that check has got no value. Do you understand that? Even if you've not handled a check, you can understand it this way. Suppose you have to give somebody money, you give a check. In check, how do we understand? In check, some money is written there, some signature is there, and it is given to some person. He goes there and encash the checks. Check had a validity only during the path time, right? Neither before it nor after it. Similarly, in thermodynamics, what we do energy transfer. Energy transfer from one place to another place. And this energy transfer takes place only through two things. One is called Q and another is W. There are just two ways only through which we can transfer energy, either by heat or by work. We have no other third method of doing it. So you can easily understand what are they doing. They are being the courier, isn't it? So they are just the energy carrier. Energy does not get transferred from one place to another on its own. It needs a courier, it needs a messenger. And what can be that messenger? Either it can be Q, that is the heat, or it can be W, that is called as work. We have no different mode. And that is why we call Q and W only as path function. Because their existence is only in the path. Their existence is only in the path. I mean, it can also be proved that Q and W is not a form of energy, to your utter surprise. Not a form of energy which we have studied till date. That heat and work is a form of energy. No. Heat and work is a mode of transfer of energy. Is a mode of transfer in energy. It just do the work of transferring energy from one place to another and nothing else. Once energy has been transferred, the role of Q has ended. Once the work has been done and the energy has been transferred, the role of work is over. It should be understood this way. And rest all the functions are state function. State functions are those functions which the value of which depends upon initial and final state only. Initial and final state. There are many parameters to ascertain state and path function. Here I told you, look, work done, you have studied in physics, force into displacement. We do like this, right? Force into displacement. You must have heard it. F dot ds. We write. Now, we also know that pressure is equal to force per unit area, right? So for force, we can write that pressure multiplied by area. So we can write pressure multiplied by area multiplied by ds. This can be called as work done. And this quantity can be written as delta V, change in volume. W is equal to P delta V. This we have studied in physics. But remember, with us, in chemistry, you will always be using work done is equal to minus P delta V. You will have to do it. Work done is equal to minus P delta V. And it will be in accordance with the, the convention that we studied in the beginning. As I told you, convention in chemistry is heat given to the system positive. Heat given to the system. Heat given to the system, it is positive. Work done on the system, positive. These are the two things which are positive. Heat, the transformation of energy from one body to another, which differ in their temperatures, is called as heat. We discussed about heat. Heat is measured in calorie or joules. Heat capacity, very important term. Heat capacity. The heat required, the amount of heat required to raise the temperature of 1 gram of a substance or system by 1 degree is called as specific heat. We have two different type of, look, first we talk about heat capacity. Heat capacity is generally term used for a body, any body. Specific heat capacity. Specific heat capacity is for 1 gram of a substance. For 1 gram of a substance. And molar heat capacity. Molar heat capacity for 1 mole of a substance. These are the terms which are used. Heat capacity for a body, specific heat capacity for 1 gram of a substance, and molar heat capacity for 1 mole of a substance. And this is basically the amount of heat required to raise the temperature by 1 degree centigrade. Let us suppose there was a body like this body. You use 5 joule of heat to raise its temperature by 10 degree, let us say. You use 5 joule of heat and its temperature changed to 10 degree centigrade. And if we are interested in finding the heat capacity, then we will have to understand, for changing 1 degree, for 10 degree 5 joule is required. For 1 degree 5 joule by 10 will be required. So in the numerator we are writing what? Q. In the denominator what we are writing? Delta T. This we call as heat capacity. C. Heat capacity C is equal to Q by delta T. And this can be expressed. This is not, for understanding it is okay. Normally we use molar heat capacity. Molar heat capacity for 1 mole of substance. And the formula given is Q by delta T. Change in temperature, amount of heat. How many types of heat capacity we have? There are 2 types of heat capacity. Heat capacity at constant volume, we call this as CV. And heat capacity at constant pressure, we call this as CP. Both CP and CV are state functions. Both CP and CV are a state function. I called you state function. State functions are those functions which are dependent on initial and final state. The heat capacity at constant volume gives the change in internal energy of the system at constant temperature. Look here, partial derivatives have been used. CV is called as partial derivative of E upon partial derivative of T at constant volume. And we use another term, Cp del H by del T at constant P. This expression is important for you. This expression is important for you. This del E by del T is actually equal to dE by dt, but just because if we are making something constant, we want to observe these things by making something constant, that's why we use a term V out here, and their sign is also twisted slightly. Del E by del T at constant V. Those of you who want to study thermodynamics at a higher level, please, for God's sake, you should be studying this part of mathematics, which is called as partial derivative, and you should make yourself familiar with this area. Then you will be in a position to solve these questions very effectively. Coming to another portion of it, what is the relationship between Cp and Cv? You will have the derivation, and I have already done it for you, but you should remember the result, Cp minus Cv is equal to R. And we have done a very small derivation if you notice it here. We have this formula that we will be studying later, H is equal to E plus PV, and then we are differentiating it and putting the values, and we are getting Cp minus Cv is equal to R, as the explanation goes like that. There is another term which is called as Poisson's ratio. Poisson's ratio is given for Cp by Cv. Cp by Cv, it is called as gamma, and this is called as Poisson's ratio. Poisson's ratio. And as I told you, this Poisson's ratio is 1.66 for monatomic gases, 1.4 for diatomic, and 1.33 for polyatomic gases. So we use it, though we have the formula to derive it, but don't go deeper into it. Remember it. Like monoatomic gases, if you are said helium, neon, argon type gases are closed inside the container. As I told you, thermodynamics is all about what? Is a gaseous system. So any gas can be there. Gases can be monatomic, gases can be diatomic. Diatomic gases, we have oxygen, O2, N2, F2, these gases are there. That can also be inside a container. We can have polyatomic gases, NO2, CO2, like these gases, which can be inside the container. So for all of them, we find out Poisson's ratio, that is gamma, and it is like that. Energy. We have different form of energy. We call this potential energy, kinetic energy. Potential energy you must have calculated is mgh. Kinetic energy, you know, half mv square. But energy can be of different types. Energy can be of different types. And we basically are interested in internal energy of the system. And we generally denote it by E or U. And at the outset, you should know that it is just not possible to measure the absolute value of E or U, and for that matter of H, S and G. We cannot measure the exact value of EU of any system. Just because there are variety of energy, we cannot generally say that this is what is called as energy. I mean, this is the value of energy. We cannot find out energy in absolute term. But yes, we can always find out change in energy. Suppose a gaseous system had E1 energy, we considered. Suppose we put Q amount of heat into it. Suppose we did W amount of work onto it, and its energy become E2. Then it is possible for us to calculate E2 minus E1, which is equal to Q plus W. Look here, what have we done? E was not possible to be found out, but change in energy is always, it can be found out, right? Internal energy and enthalpy, there is another term called as enthalpy, which is called as delta H. Delta H. Delta H is generally written as delta E plus P delta V. About internal energy or enthalpy, we will just be talking. This is internal energy, this is enthalpy. There are a variety of things that I've written. The sum of all forms of energy, both kinetic and potential energy, except gravitational energy, is called internal energy. All forms of energy, what you can think of, The sum of internal energy of a system and work form of energy of the system is called enthalpy. Like as I told you, delta H is equal to delta E plus P delta V. Enthalpy. Fine. About Altedemy, subscribe it as soon as you can. You will get free classes regularly. Your subscription is important for us. Now, first law of thermodynamics. First law of thermodynamics. The energy in a process may be transformed from one form into the other form, but it is neither created nor destroyed. As I discussed, a system had energy even. Q amount of heat we gave, W amount of work we did, its energy become E2. Then we say E2 minus E1 is equal to Q plus W. This is what is called as first law of thermodynamics. We call this as first law of thermodynamics. Look here, if we are writing this E2 minus E1 is equal to Q, or W if we can write what? Minus P delta V, which means E2 minus E1 is equal to Q minus P V2 minus V1. And from here you can work out E2 plus PV2 minus E1 plus PV1 is equal to Q, and this term only is called as enthalpy. We name this H2. Like this is H2 minus H1 is equal to Q. H is equal to E plus PV. Delta H is equal to Q. First law of thermodynamics. Law of conservation. The mathematical form I just explained you very briefly, that what we write, that delta H is equal to delta E plus P delta V. Well, I have written this convention in chemistry very formally. Heat absorbed by a system or other heat given to a system is called as positive. Obviously, opposite of it, heat given by a system is called as negative. Work done on the system is positive. Work done by the system, that we call this as negative. The repercussion of IUPAC convention is, as I discussed, what? Work is equal to minus P delta V in chemistry. Work is equal to minus P delta V in chemistry. You will always be writing this. I can prove it. Suppose there is a container and there is a piston out here, right? Its volume is, let us suppose, V1, and you have done some work onto this system. Now the piston comes here. Now the volume becomes V2, let us suppose. If we try to calculate delta V, which is equal to V2 minus V1, obviously this quantity will come into negative. Don't you think? V2 minus V1 will be coming in negative because V2 is smaller, V1 is larger. If you use the formula of physics, work is equal to P delta V, then obviously it is coming, pressure is positive, then this is coming to be a negative quantity. But you know better, if you will do work onto the system, then only it will come. And as per our convention, work done on the system, it should happen what? Positive. If we understand that work done on the system positive, by using the physics formula, it is coming to be negative. So we discarded this formula in chemistry and we started writing W is equal to minus P delta V. W is equal to minus P delta V. This is what the repercussion is. You will also be writing one and the same thing. We have two different types of reaction that we come across or we discuss. One is exothermic type of reaction. Exothermic reactions are those reactions where heat is liberated. Heat is liberated. Endothermic reactions are those reactions where heat is being absorbed here. Probably you know that exothermic reactions are these, endothermic reactions. If you want to have a representation of exothermic reaction graphically, it will always have a shape like this. And if it is like this, it is endothermic process, right? Like this. Here we have the energy chart. Here we have, you know, time, you can say. This is where reactant lies. This is where product lies. And this is delta H. This is the process of exothermic. Reactant is at a higher energy level, product is at a lower energy level. Here reactant is at this level, product is at this level. So it will be absorbing energy, then only it will come to this stage. So delta H is this. Fine. So exothermic and endothermic process. When we are writing those reactions, we call them as thermochemical equation. Thermochemical equations are those equations, the balanced chemical equation accompanied with the enthalpy changes of the process is called thermochemical equation. The physical states of the reactants and the products were mentioned in the bracket. For gaseous substance as G, for liquid substance is L, for solid substance is S, and for aqueous solution is AQ. We use generally S, L, G, AQ like this. Thermochemical equations. We also talk about standard state in basic thermodynamics. And the standard state is what? The most common physical state of a substance is at 1 atmosphere and 298 Kelvin, and it's called at a standard state. We also take this as STP. The enthalpy of an element in its standard state is taken as 0. The enthalpy of an element in its standard state is taken as 0, and we define various types of enthalpies. What are those various types of enthalpies? That I will elaborate. What are those various types of enthalpies? You will come across various types of reaction, like first is called as enthalpy of reaction. Enthalpy of reaction. During the process of a reaction, how much heat has been liberated or how much heat has been absorbed, that is called as enthalpy of reaction. You must have noticed, like if you have a reaction like A plus B giving us C plus D, there is a semicolon here, and delta H, if it is negative, it is exothermic a process. And if A plus B is giving us C plus D, if delta H is positive, then it is called as endothermic process. A semicolon and then delta H is written. So various types of reaction that we come across. One is called as enthalpy of reaction. Another we call this as enthalpy of formation. Very, very important. Enthalpy of formation. Suppose we are forming a substance like NH3 and it has been made from nitrogen and hydrogen. Then you are not at the liberty of writing each N plus 3H gives us NH3. No. The elements are always written in their standard state. And we should know about that beforehand. We should know that N2 exists as N2, nitrogen exists as N2, and hydrogen exists as H2 to give us NH3. Now this has to kept at 1 mole only. So here by hook or by crook we will have to write 1 by 2, and here we will have to write 3 by 2 to get this NH3 here. Right? So the enthalpy of formation for this reaction will be written like this. Similarly, we can have enthalpy of combustion. Enthalpy of combustion. What will happen in enthalpy of combustion? Suppose a substance. Hi Mahant, you are very late. Anyway, you will be getting the video version of this thing. Enthalpy of combustion. Let us suppose we are taking carbon, we are taking oxygen, and it is giving a result as CO2. Whatever is undergoing combustion, for that we need 1 mole. So in this process, when it is made to react with oxygen, CO2 is forming. Whatever amount of energy is liberated or absorbed. Combustion is basically an endothermic process. I'm sorry, combustion is an exothermic process. Heat is always released when combustion takes place, right? Combustion. So exothermic combustion is essentially an exothermic process. So we have these processes that we can say. Besides, we have other processes like enthalpy of neutralization. Enthalpy of neutralization. We have other enthalpies also. Enthalpy of solution. Enthalpy of solution. You will find many applications there: combustion, solution, and neutralization, and other things. And the amount of heat involved in that particular process is called as enthalpy. Enthalpy is always about 1 mole. So I think you could have understood a little bit about thermodynamics and the basics of thermodynamics. I had a claim to make you understand the basics of thermodynamics only. So I have talked just the basic things as far as thermodynamics is concerned. Come to Altedemy. This is very important to know about you. We are trying to bring you onto the platform Altedemy, and it will be a great advantage for you also. By paying very less amount, you can join our courses, and the course comprises 90 plus classes, in fact more than 120 classes. It's a very convenient educational platform where, as far as NEET coaching is concerned, the syllabus has been prepared by NEET experts. We have flipped classroom methods. We have doubt solving practices that we are doing it regularly. How our classes look like? What do we do basically in our classes? Whenever you will be attending our classes, whenever you will be joining our classes, you will be getting chapter wise theory of all those what we are studying. Theory is one thing that you will be getting beforehand. There will be one classroom presentation which also comprises the entire study material, which we call this as a study material. So there are two things. There are two forms in which this material is going to you. One is going in the form of theory, another it is going in the form of study material to you. And we communicate you with the process of webinar as we are doing right now. Through webinars, we try to cover many things to you. We give you plenty of homework, and we do the discussions of all those homework with very good presentation and all those things. And then there is a provision of homework check also that we are doing. Join our Altedemy without wasting even a single day. We have different kinds of program. We have a light program, we have a smart program, we have a proficient program. In the light program, we talk about interactive live classes, we talk about structured courses and PDF, we talk about live tests, we talk about physical notes. I think that will serve the purpose, but our smart program is the best program that you can choose to have. In the smart program, we are giving you interactive live classes. We have structured courses, live test, physical note, and one-to-one mentorship. Anytime you can talk to any of our faculty, physics, chemistry, mathematics, and biology. There are live doubt solving programs. You come with a problem, float the problem into our group, you will find the solution of that particular thing, be it physics, chemistry, maths, or bio. We are conducting mock tests regularly. What else do you want? We have all packed all those things in our smart package and invite you to be with us. Join without making any delay. And all those things is coming on a special price for just 1 month with a promo code that I am giving you. This is NEET CHEM 30. Net Chem 30. It is for all of you who are with me. Join it as fast as possible. It is just for 299 rupees. You waste it for any damn cause. Join it. It is just for a month. You will get plenty of benefits. This is my assurance. Thank you very much. See you soon. Thank you guys. Thank you very much for joining us. I hope you will be joining Altedemy platform very soon. Soon to see you in all those things. You can chat with me in the group and we can have all our queries satisfied into that. I hope you must have enjoyed the entire session. Thank you.